Diophantine equation is of the form ax plus by is equal to c. Now we want to solve this equation to find values of x and y. This equation is solvable if and only if GCD of a and b divides c, and if this d divides c, then we can easily find a particular solution x naught and y naught. All other solutions of given Diophantine equations can be evaluated using these two relations where t is an integer. Now let's see the application of this method to solve a Diophantine equation. So we start with finding GCD of 18 and 5 using Euclidean algorithm. So for that we divide 18 by 5 and we get quotient 3 and remainder 3. Now we divide 5 by 3, quotient is 1, remainder is 2. Now we divide 3 by 2, quotient is 1, remainder is 1. Now we divide 2 by 1, quotient is 2, remainder is 0. So we know the last non-zero remainder is the required GCD. So here the GCD of 18 and 5 is 1, and clearly 1 divides 48. So the given Diophantine equation is solvable. Now to find particular solution, we use back substitution. We express GCD from this equation as 3 minus 1 into 2. Now putting the value of 2 from this equation, we get 5 minus 1 into 3, which is further combining the same terms. This is 2 times 3 minus 1 times 5. Now putting the value of 3 from first equation, we get 18 minus 3 into 5 minus 1 into 5, which is further 2 into 18, 2 into 3, 6, minus 6 minus 1, minus 7 into 5. So this is 1 is equal to 2 into 18, 7 into 5. But here we have to remember the given equation is of the form 18x plus 5y is equal to 48. This is actually A, B and C. So we have to complete it C. So for that we will multiply this equation by 48. So it becomes 48 times 96 into 18, 336 into 5. So very easily we can write x naught is 96, y naught is minus 336. Using the theorem of Diophantine equations, all other solutions are expressed as x is equal to x naught plus bt when GCD is 1, which imply x is equal to 96 plus 5t and y is equal to y naught minus 80, imply y equals to minus 336 minus 18t. To find the positive solution, we put x strictly greater than 0 and y strictly greater than 0. So it becomes 96 plus 5t strictly greater than 0, imply 5t is strictly greater than minus 96, t is strictly greater than minus 96 by 5, which is minus 19.2. And from the second equation, minus 336, 18t strictly greater than 0, imply 336 greater than 18t, t is less than minus 336 by 18, which is minus 18.6. So let's see on the number line how many values lie between this. Now let's see, this is minus 18, this is minus 18.6, this is minus 19, minus 19.2, and so on. So we can easily see there is only one value which lie between this. So here t is greater than 19.2 and less than 18.6, and the only value that lie between this is t is equal to minus 19. So then putting the t in x and y, x is 96 plus 5 times minus 19. After evaluating, it is 1. Y is minus 336 minus 18 minus 19 equals 6. So here the answer is x is equal to 1 and y is equal to 6. Another question is, find all positive solutions of 54x plus 21y is equal to 906. Here this is A, this is B, and this is C. So we start by finding GCD of 54 and 21. By Euclidean algorithm, we divide 54 by 21. Quotient is 2, remainder is 12. Divide 21 by 12. Quotient is 1, remainder is 9. Divide 12 by 9. Quotient is 1, remainder is 3. Divide 9 by 3. Quotient is 3 and remainder is 0. So last non-zero remainder is the required GCD. And clearly 3 divides 906 means given Diophantine equation is solvable. Now we use back substitution, express 3 as linear combination of 54 and 21. Firstly, we have 3 is equal to 12 minus 1 into 9. Putting the value of 9 from this equation, 12 minus 1 into 21 minus 1 into 12. Combining the coefficient of 12, that is 2 times 12, 1 times 21. Putting the value of 12 from first equation, 2 times 54 minus 2 times 21, 1 times 21. So we further have 3 is equal to 2 times 54 minus 2 2s are 4, minus 4 and minus 1, minus 5 times 21. But here C is 906. To complete this constant, we multiply this equation by 302. So it is 906 on this side, and here we have 604 times 54, 1510 times 21. So here x naught is 604, y naught is. Now to write the general solution of Diophantine equation, we use again the formula, that is x is equal to x naught plus b by t times t. So putting the values, x naught is 604 plus 21 by 3 times t, and further this is 604 plus 70. And y naught minus a by d times t. So putting the values, 1510 minus 54 by 3 times t, that is minus 1510 minus 18t, where t is integer. Now to find positive solutions, we put x strictly greater than 0 and y strictly greater than 0. So from x we get 604 plus 70 strictly greater than 0, and from y we get minus 1510 minus 18t strictly greater than 0. So from here we can easily find t is strictly greater than 604 by 7, so which actually comes out, this is minus 86.28, and from here we get t less than minus 1510 by 18, which is minus 83.88. So let's see on the real line where the points lie. So here we have 86.28. This is minus 86, 85, 84, 83.88, minus 83, minus 82. So the required values are three values of t. So we get t is equal to minus 86, minus 85, minus 84, and x is 604 plus 70, and y is minus 1510 minus 18t. So putting 86 first, 604 plus 7 times minus 86 will comes as 2, minus 1510 minus 18 times minus 86 will comes out 38. Second solution, we get 9, 20, 604 plus 7 times we get 16, we get 2. So we get three solutions, 2 and 38, 9, 20, 16, 2. Answer. So in the next question, the neighborhood theater charges $1.8 for adult admissions and $0.75 for children. On a particular evening, the total receipts were $90. Assuming that more adults than children were present, how many people attended? Now let's suppose, let X be number of adults and Y be number of children. Then we are given adult ticket charges is 1.8. So let's convert this $1.8 into cent. It is 180 cent. And for children it is 0.75. So this is 75 cent. And total collection is $90. So in cents this is 9,000. So the equation becomes 180x 75y equals 9,000. So here this is A, B, C. So using Diophantine equation method, first we find a particular solution. For that purpose, first we need GCD of 180 and 75. So we divide 180 by 75. Quotient is 2, remainder is 30. We divide 75 by 30. Quotient is 2 again and remainder is 15. Divide 30 by 15. Quotient is 2, remainder is 0. So last non-zero remainder is the GCD, that is 15. So GCD is 50. Now let's express this 15 as the linear combination. So from this equation, 15 is 75 minus 2 into 30. Now from first equation, put value of 30 as 180 minus 2 into 75. Coefficient of 75, we have 2 to the 4 plus 1, 5 times 75, 2 times 180. So we have 9,000 on the left hand side. So we multiply this equation by 600. 9,000 is equal to minus 1200 times 180 plus 3,000 times 75. So clearly we can write x naught as minus 1200, y naught as 3,000. So we get one particular solution. Now all other solutions can be expressed as x is equal to x naught plus b by d times t, that is minus 1200 plus 75 by 15t, which is minus 1200 plus 5t. And for y it is y naught minus a by d times t, that is 3180 by 15 times t, which comes out 3000 minus 12t. Now to find positive solutions, we put x strictly greater than 0, which imply minus 1200 plus 5t strictly greater than 0, that is 5t strictly greater than 1200 and t is strictly greater than 240. For y strictly greater than 0, 3000 minus 12t greater than 0 imply t less than 3000 than 250. 241 to 249. So t equals 241, 242, 243, 244, 245, 246, 247, 248, 249. And we know x is equal to minus 1200 plus 5t and y equals to 3000 minus 12t. So putting 241, we get 5 and y 108. Now putting 242, it is 10 and 96. 243, it is 15 and 84. 45 and 12. As asked in the question that more adults than children are there, so x greater than y happens in these two cases. So the solutions are 40 and 24 and 45 and 12. Answer. A certain number of 6s and 9s are added to give a sum of 126. If the number of 6s and 9s is interchanged, the new sum is 114. How many each were originally? So we let x be number of 6s and y be number of 9s. So the equation becomes 6x plus 9y equals to 126. And in the second part, it has been said that 6s and 9s are interchanged. So the equation becomes 6y plus 9x. And the new sum is 114. So here we have to solve two sums using the method of solution of Diophantine equation. Then the common solution among these two will be our final solution. Purpose, first we find GCD of 6 and 9. We divide 9 by 6. Quotient is 1, remainder is 3. Divide 6 by 3. It goes on 2. Remainder is 0. So GCD is 3 here. So clearly 3 divides 126. The given equation is solvable. And the particular solution is written as 3 is equal to 9 minus 1 into 6. And we want 126 here. So we multiply it by 42 to get 126 is equal to 42 times 9 minus 42 times 6. So here x naught is minus 42 and y naught is plus 42. And general solution, that is x naught plus b by d times t, is given by minus 42 plus 3t and y as y naught minus a by d times t as 42 minus 2t, where t belongs to set. Now to have positive solutions, we put x strictly greater than 0 and y strictly greater than 0. So we get minus 42 plus 3t greater than 0, 3t greater than 42, t greater than 14. And to get y positive, 42 minus 2t greater than 0 imply 42 greater than 2t imply t less than 21. So the value lie between 14 and 21. Let's find the solutions. So t is 15, 16, 17, 18, 19, 20. And x is given by minus 42 plus 3t and y is plus 42 minus 2t. So putting 15 we get 3 and y as 12. By 16 we get 6, 10, 18, 2. So this is solution for first equation. Similar way we will solve the second equation, that is 6y plus 9x is equal to 114, or we may write it as 9x plus 6y is equal to 114. So similarly we first find the GCD of 9 and 6 very easily, that is 3 is equal to 1 into 9 into 1 into 6 as we have done previously. So we have 114 here. So clearly 3 divides 114. So this equation is solvable. So we multiply this by 38 to get 114 here. So this is 38 into 9, 38 into 6. So x naught is 38 and y naught is minus 38. This is the particular solution, and the general solution is given by x is equal to x naught plus b by d times t, that is 38 plus 2t, and y is y naught minus a by d times t, that is minus 38 minus 3t. So to have the positive solution, put x positive, imply 2t greater than minus 38, t greater than minus 19. Now y positive, so we put 3t less than minus 38 and t less than minus 12.6. So t lie between less than 12.6 greater than minus 19. So the values of t are minus 18, minus 17, minus 16, minus 15, minus 14, minus 30. And x is 38 plus 2t and y is minus 38 minus 3t. So putting first value minus 18, so it is 2 and 16. Putting minus 17, it is 4 and 13, 12 and 0, 1. So these are the solutions of x and y for second equation. Now we have to look for the common solution which is common in both. So you can easily see there is one solution 6 and 10 that occurs in this equation as well as here. So the final solution is x is equal to 6, y is equal to 10. Answer. 100 bushels of grain are distributed among 100 persons. Means we have x men, y women and z children, and given x plus y plus z is 100. In such a way that each man receive 3 bushels, each woman receive 2, and each child receive half. How many men, women and children are there? So total 100 are distributed among 100. So second equation is 3x plus 2y plus half z is equal to 100. So but the Diophantine equation we have learned is ax plus by equal to c. So very easily we can put the value of z from this equation into second equation. So it becomes 3x plus 2y plus half times 100 minus x minus y equals to 100. So after solving, this equation becomes 5x plus 3y equals to 100. So clearly this is A, B and C. So first we find GCD of 5 and 3, which comes out of 1 because they are relatively prime. Clearly 1 divides 100. The given equation is solvable. So let's write the steps by Euclidean algorithm to get particular solution. So we have quotient 1, remainder 2, quotient 1, remainder 1, quotient 2, remainder 0. So here 1 is the GCD. Now let's express 1 as the linear combination. 3 minus 1 into 2, 3 minus 1 into 5 minus 1 into 3. So this is 2 into 3 minus 1 into 5. So we have 100 on the left hand side. So we multiply it by 100 to get 100 here. 200 times 3, 100 times 5. You can easily verify this is 600 minus 500 is equal to 100. So x naught will comes out. X naught is coefficient of 5. So that is minus 100. And y naught is coefficient of 3, that is 200. So this is how we get particular solution. Now the general solution is x is equal to x naught plus b by d times t. Here d is 1. So very easily this is 100 plus 3t, and y is y naught minus 80, and y naught is 200 minus 5t, where t belongs to z. To find the final solution, we put x strictly greater than 0 and y strictly greater than 0. Let's see. Minus 100 plus 3t greater than 0 imply 3t greater than 100, t greater than 100 by 3, that is 33.33. Y strictly greater than 0 means 200 minus 5t greater than 0 imply 5t less than 200, t less than 40. So t lie between 33.33 and 40. So it is from 34 to 39. So let's write the values here. So t is 34 and x is minus 100 plus 3t, and y is 200 minus 5t, and also we know z is 100 minus x minus y. So putting value of t as 34, we get 2, 30, and putting both values here, we get 68. Putting 35, 5, 25, 76, 17, 5, 78. So this is the solution here. We have divide 100 into two summands such that one is divisible by 7 and other by 11. Let x be the summand divisible by 7 and y be the summand divisible by 11. So the equation becomes 7x plus 11y is equal to 100. This is A, this is B, this is C. So we start by division algorithm, that we divide 11 by 7. Remainder is 4. We divide 7 by 4. Remainder is 3. 4 by 3. Remainder is 1. Divide 3 by 1. Remainder is 0. तो लास्ट नॉन ज़ीरो रिमाइंडर इज़ 1. तो क्लियरली GCD of 7 and 11 is 1 and 1 divides 100. तो given equation is solvable. So by back substitution we express 1 as linear combination of 7 and 11. This is 4 minus 1 into 3. Putting the value of 3 here, 7 minus 1 into 4. So combining the coefficient of 4, this is 2 times 4 into 1 times 7. Putting the value from first equation here, 2 times 11 minus 1 into 7, 1 into 7. This is 2 times 11 minus 2 and minus 1 is minus 3 times 7. So what we have 100 here, so we multiply by 100 to have the same form. 200 times 11, 300 times 7. So here is very easily x naught is coefficient of 7, that is minus 300. Y naught is coefficient of 11, that is 200. So we get a particular solution here. Now let's write the general solution. X is x naught plus bt. X naught is 300 plus 11t. Y is equal to y naught minus 80, that is 200 minus 70, where t belongs to z. So these are general solution. Now to get positive solution, we put x is equal to 0. Imply t is greater than 300 by 11, that is 27.27. Now y greater than 0, imply t is less than 200 by 7, that is 28.7. So t lie between 27.27 and 28.57. So there is only one value, that is 28 here. So let's put t 28. So x is minus 300 plus 11 times 28. So it is 8. Y is 200, 7 times 28, that is 4. So the answer is 8 and 4.